Hi, welcome to Exploring the Illusion of Free Will. My name is George Ortega, and today is June 2nd, 2014, and this is episode number 160. The title of this episode is Free Will, Refutation, Cost, Climate Change Denial, Part 3. And basically in this series, we're reviewing a book that I just published in April, a scholarly work called Free Will, Its Refutation, Societal Cost, and Role in Climate Change Denial. And essentially in it, it has two original contributions to the literature on human agency, on free will versus determinism. The first is that it presents the argument that the causality that makes free will impossible, scientifically, logically impossible, is so undeniable, so indisputable, that it's to be regarded as a priori knowledge. Now, a priori means that it's so self-evident that it's unquestionable. And very quickly, the way I arrive at this is like basically the first a priori truth of the universe is that it exists. You can't deny that. No one can ever deny that. It could be someone's dream, who knows, but the fact that it exists is irrefutable. Okay, the second fact of the universe is that it's in motion. It changes. Change is the fundamental process of the universe. So when you ask yourself what change is, and physics describes this, change is really a particle, any particle, being at one position at one moment in time and in a different position in the next moment in time. So then when you ask yourself what explains that change, in physics they have a term that's called momentum. It's, the motion is described by the velocity and direction of the particle, and it's caused by something. It's generally caused by one of the four forces of nature: gravity, electromagnetism, the weak nuclear force, or the strong nuclear force. So basically, by understanding the change requires causality, you also understand that causality is as fundamental or as a priori a fact of nature as is the fact that change exists and the fact that the universe exists. Okay, and so it's important because as I'll get into in this episode, back around 1927, a guy named Heisenberg, a physicist, came out with what was referred to as the Heisenberg uncertainty principle. That I'll get into it a bit later. But anyway, there was a challenge. Some people began to question whether, in fact, everything was caused. All right, before getting into this, I just want to describe very briefly what people mean when they say we have a free will and why we simply don't. Basically, if we had a free will, what we did would be fundamentally up to us. We would be fundamentally morally responsible for what we did because we would be causing it. Nothing that was not in our control would be compelling us or making us think and say and do and feel what we do. Now, naturally, if everything is caused, if causality is this a priori fact of the universe, that means that everything we do has a cause, and there's a cause to the cause of everything we do, and there's a cause to that cause and a cause to that cause. And through this chain of cause and effect, the causal antecedents to every human act would regress back in time to before we were born, okay? And one way to understand this, well, I'll get into this later. All right, so we're going through this book. It's a 56-page book, but it is profoundly important. Not only does it pretty much, in a certain sense, end the free will determinism debate by demonstrating that the causality that refutes it is a priori. It's undeniable. But more importantly, perhaps now, because alternatives to causality also refute free will. But more importantly, I think, is that it implicates free will belief in climate change denial. And I'll get into that later. I went into it a bit on the last two episodes. Well, essentially, might as well do it now. All right. About 66% of Americans are in denial that climate change is happening. They believe it's not happening. They believe it's not happening. There's not sufficient evidence to demonstrate that, and that we're not, human beings aren't causing it. Okay, so they're in denial. So what is denial? We deny things that we can't face. If you're accused of something, and what you're accused of is so horrible that you can't face the fact that that you did it, you would unconsciously deny that you did it. You deny whatever you're being accused of. So apply this, and in order to, what happens is like you would deny it because you'd feel guilty. Somebody's accusing you. That prospect that you did something so horrible makes you feel not just guilty but scared, afraid, whatever. Maybe afraid of punishment, whatever. So the point I make in this book is that, like, in order to feel guilty or responsible about doing something and then go into denial about it, like we're in denial about climate change, you first have to believe you have a free will. If you understand you don't have a free will, and this is the benefit of this book to really the entire climate change crisis, the denial aspect of it that's preventing us from doing so much we should be doing, to the extent you understand that we don't have a free will, you will not feel guilty, even though you recognize that human actions are causing it, and we need to do a lot to change our world, to adapt to climate change and to mitigate it, to lessen its impact on the future. But we can do this much more effectively by overcoming our denial of it, by first overcoming the illusion of the belief in free will. To the extent we don't believe in free will anymore, we won't have a reason to feel guilty that we're causing it, and that guilt won't unconsciously lead to our denial of it. In other words, like when we feel guilty about it, we can't face the evidence squarely, objectively. So, like, to the extent we overcome free will belief, we will be able to look at the evidence, conclude it's happening, and make progress on it. Okay, so we're we're on page 4, 56-page book. It's a very, very important book. It's a scholarly work again. It's on Amazon if you want. But again, if you watch these shows, you won't have to buy the book. All right, so basically, a lot of confusion about whether we have a free will or not is like, back before quantum mechanics started in the early 20th century, the early 1900s. And before that, it was pretty evident, based on Newton's laws of motions, based on the science back then, classical mechanics, classical physics, that everything has a cause, that everything is caused, nothing happens without a cause, and as we just, saw a few minutes ago, that makes free will completely impossible. But what happened was like that, there's a guy, Simon de Laplace, that wrote a book in 1814, and he's kind of like, he's applying this principle of causality to prediction. He's basically explaining the implications of causality in prediction. So basically, what he said in the book was, and basically the operative word here is if. He said, if we could know everything about a state of the universe at any given moment, we would, by that knowledge, be able to predict anything about a future state of the universe and also know anything about a past state of the universe. Okay, so that's what's classically understood as the description of determinism. It's the implication that if everything is causal, then in theory, if we had all the information necessary, we would be able to, again, completely accurately predict the future and completely accurately know the past. And so, like, what happened was that then, again, in 1927, all right, now, before that, okay, again, the key part here is, like, it's important to understand that causality and determinism are not mutually dependent, nor are they completely identical. They're related, but essentially it's like causality is the fundamental law of nature, and determinism is the implication of causality, again, if we had all the information necessary to make a prediction. Now, all right, before we even get into this, the first obvious fact is we can never know everything about the universe. Just like, maybe in principle we can. If like, in other words, if there's a God or if the universe is conscious, maybe it can know it. But we as human beings, as subjective beings on this little planet, can't. But it goes deeper. So in 1927, a guy, Werner Heisenberg, published his paper demonstrating that it is in principle impossible for us to know everything about any state of the universe. Let me just cite the book. All right, not the book, it was a paper, and it was the title of the paper was On the Physical Content of the Quantum Theoretical Kinetics and Mechanics, and it's got this title in German that if I even tried to pronounce it, I would, do it injustice. And it's like, maybe I can get the title of the journal it was published in right. Zeitschrift für Physik or Physik or something. So anyway, so it's a pivotal paper. Basically, it's he presents what's known as the Heisenberg uncertainty principle, HUP. And basically in it, he proposes, he explains mathematically, and you can't contest this. This is like, if you're a physicist, you have to contest this. This principle is so robust, it is really irrefutable. And we'll get into why it's irrefutable later. But basically, he said that you can't simultaneously measure the position and momentum of a particle with enough accuracy to render a prediction. Okay, and so here's the thing. So because of this, and he's right, and I'll go into this later, but because of this fundamental prohibition against this simultaneous position momentum measurement, some people concluded, well, if we can't predict, completely accurately because of this Heisenberg uncertainty principle, maybe there's an opening for free will. Or maybe that means that everything isn't caused. But as we'll see as we go through this, no, that there's any kind of a conclusion based on Heisenberg uncertainty principle that one, either nature is acausal, or two, that the fact that we can't perfectly predict the future or know the past means that somehow we have a free will. Those conclusions are completely groundless. They're not based in either logic or science. Okay, so so what happens is it's called the Heisenberg quote unquote uncertainty principle that led some physicists, philosophers who really should have known better because it's not so complicated. They said, well, that means that the particle is behaving in an uncertain manner. In other words, because we are uncertain about how the particle is behaving, because we're uncertain because we can't simultaneously measure its position and momentum, that means that the particle is behaving uncertainly, with uncertainty. Okay? I refute this. I'm going to read my refutation to this because it's succinct and it just demonstrates the illogic of that kind of conclusion. So on page 5, I say, however, not knowing the simultaneous position and momentum of a particle forms no basis for logically concluding that its behavior is either caused or uncaused or uncertain, and one's ignorance or uncertainty about the behavior of a particle in no way justifies a claim that the particle is behaving in an ignorant or uncertain manner. So obviously, if we're ignorant of the nature of the behavior of a particle, it makes no sense to therefore conclude that the particle is behaving ignorantly. So in that same way, if we're uncertain about certain aspects of particle behavior, because of the prohibitions imposed on by Heisenberg uncertainty principle, that in no way justifies a conclusion that the particle behavior is in fact uncertain. We are uncertain about its behavior. Its behavior is not fundamentally uncertain. And because what does uncertain mean? In other words, the idea that they're trying to present here is that this fundamental uncertainty means that that the particle behavior isn't being caused. I'm going to refute that later, but again, we are uncertain of the particle behavior. The particle is not behaving uncertainly. Okay, so now how do we know this? How do we know that that even though we can't simultaneously measure the position and momentum of a particle at the quantum level because of the Heisenberg uncertainty principle. How do we know that that particle behavior is caused? Well, we know it, as I explain on page 5, because that the act of measurement is what prohibits our knowing the simultaneous position momentum, and the act of measurement is what causes all right, no. let's see. All right, the reason we can't, this gets a little complicated. The reason we can't simultaneously measure the position and momentum of a particle is because, like, for example, let's say there's a particle, like electron or something, and the way we measure particles in the quantum world is we'll fire another particle at it, let's say a photon, and the photon will bounce off the electron, we'll detect that interaction, that collision, and that'll give us some information. But here's the problem. The problem is when the photon bounces, collides with the electron, the impact changes the particle's behavior. In other words, that actually results if you're using a high energy, short wavelength photon. You know, it's just like you can precisely measure the position, but the collision alters the particle's momentum. Now, you can get around that. You can use actually a low energy, long wavelength photon to fire at the particle, but because of its long wavelength, low energy, it's not going to give you the position. It can only give you the momentum of the particle. So you can either have accurate information about the position or the momentum of the particle. You can't have accurate information about both simultaneously. Just as an explanation, in the macro world, you know, we're describing like particle behavior, but like in the real world of everyday objects, let's say you fired a photon at a basketball. You want to like simultaneously measure its position and momentum. You can do that because, like, you know, even though the impact is going to like shift the momentum of the basketball slightly, you know, because of the difference in size between the photon and the basketball, that change is going to be so slight that the prohibition imposed by Heisenberg uncertainty principle is so small as to be insignificant. So in other words, we can measure, you know, we can in fact, you know, use classical mechanics, Newtonian mechanics to simultaneously measure the position and momentum of macro, you know, real world objects. And the Heisenberg uncertainty principle, even though it applies, its effect is so small that we can nevertheless, you know, very accurately predict. So like the problem is, like at the quantum level, the prohibitions of the Heisenberg uncertainty principle become much, much larger and prohibitive. Okay, so the idea is, one of the proofs of causality is like, it is because, hold on, I'm going to read this because, all right. Yeah, I'm going to read it because I think it's a bit complicated. I think if I read it, you'll understand it a bit better. Okay. So, okay. The change in the momentum of the measured particle was caused by its interaction with the measuring particle. In other words, like if you fire a photon at an electron and the electron changes its momentum, that change is caused by the interaction. So that's a causal reaction. That's a demonstration in the quantum level that causality exists, that, you know, causality governs the quantum level. So like basically, I go on to say, this is known unequivocally, you know, that the momentum of the measuring particle is caused by its interaction. This is known unequivocally because the causal relation is a result of the Heisenberg uncertainty principle. This is very important now. If the measuring particle did not cause a change in the momentum of the measured particle as stipulated by the Heisenberg uncertainty principle, one could, in fact, simultaneously measure the position and momentum of a particle. In other words, like, if it were possible to fire a photon at the electron and that photon, that interaction didn't cause a change in the electron's momentum, we could, in fact, simultaneously measure the position and momentum of that electron. So Heisenberg basically stipulates that, you know, its prohibition against that measurement is another way of understanding the fundamental causality, you know, that governs both at the macro or classical level of physics and the micro or quantum level of physics. Okay. All right, so let's see. We've got about 7 minutes. So yeah, basically we're saying that causality is fundamental to how the Heisenberg uncertainty principle, or why the Heisenberg uncertainty principle prohibits simultaneous position momentum measurement of particles. Okay, and I just like later in the page I go on into you know, the high energy short wavelength photon and the other, but we covered that, you know, a few minutes ago. So so again, there is nothing on page 6 about these interactions, nor about Heisenberg uncertainty principles prohibitions that they suggest that they occur in an uncaused manner. Okay, in other words, so basically the idea is that both the macro and quantum levels of nature are causal. You know, they're governed by this a priori law of causality that makes, incidentally, just free will completely scientifically, you know, categorically impossible. Okay. Now, let's see. All right, here's another way. So now on page 6, I go into another way of describing how we can understand that causality, the law of cause and effect, governs everything. Okay, it governs the entire universe. And this is, so I quote Laplace again in his book, 1814 book. He says, we ought then to regard the present state of the universe as the effect of its anterior state and the cause of the one which is to follow. So basically, Laplace is applying this principle of causality to the entire universe, okay, to the universe as a whole. And a good way to understand this is like, let's start with the Big Bang, because we don't really know what happened before then. We kind of like assume something must have happened, but there's no way of our knowing this. So like if we start, at least for now, if we start with the Big Bang, you know, the state of the universe at that Big Bang was what caused the state of the universe at the next moment. Okay, and in other words, like, so the universe is evolving state by state, moment by moment. So the second state of the universe caused the third state state caused the fourth. In other words, let me read this another time. We ought then to regard the present state of the universe as the effect of its anterior state and the cause of the one which is to follow. Let me just explain this very directly. All right, this present state of the universe, the entire universe, everything within it also, every particle interaction, everything that's happening within the universe is the complete causal result of the state of the universe at the previous moment. Okay, that's what he's saying. And it's going to and this state, present state of the universe, it's going to be the complete causal explanation, complete causal mechanism for the next state of the universe. Okay, so the idea behind this is like, sometimes scientists will say, well, you know, we can't know what causes some reactions in nature, like radioactive decay, certain entanglement, certain aspects of this double slit experiment in quantum mechanics. We can't know what's causing it, so how can we assume that it's caused? It doesn't make sense, but some scientists claim that. Well, the answer to that is, as Laplace just explained, we can know. In other words, the cause of everything happening at this moment in the universe, and it could be like my just moving my hand, my saying what I'm saying, is completely described by the state of the universe at the previous moment. In other words, the causality, any specific event that's happening now in this present state is completely caused by the state of the universe in preceding states. And that, again, the reason for that is because nothing can escape the causal evolution of the universe. In other words, to say that my hand motion wasn't caused by the previous states of the universe, this in cause and effect manner, would be to assert that this hand motion somehow is taking place outside of that universe. And obviously that's impossible. Okay, so let me read this again so to be very clear. The bottom of page 6. The state-by-state evolution of the universe completely describes the causal mechanism involved and also governs all events occurring within. For example, any specific event within the second moment of the universe was caused by the Big Bang event. So that means, thus, every human decision is caused by antecedent states of the universe that originated with and were determined by that event, the Big Bang event. So all right, the next thing, this is good. A freely willed event must be free from, now on page 7, the determination of any entity, event, or process over which the human has no control. Okay, so in other words, to have a free will, we'd have to our decisions would have to be up to us. Nothing that's not in our control could be controlling our decisions for us. Now, naturally, we didn't control the Big Bang. We don't control this law of cause and effect. We don't control the causal evolution of the universe. So if we don't control these processes, these events, these fundamental laws of nature that are actually compelling our every action, obviously that's an excellent explanation of how we simply don't have a free will. The laws of nature prohibit it. The fundamental causality at the heart of nature prohibits it. All right, we're running out of time. Basically, again, this is part 3 of this series on this book called Free Will, its Refutation, Societal Cost, and Role in Climate Change Denial. And I'm going to go through the whole book. Well, I don't know, it may take 10, 20 parts, but we're going to do this. So thanks for watching, and I'll see you again next time on Exploring the Illusion of Free Will. Thanks for watching.